In this video, I'm going to solve AQ exam another question that is related to equilibrium of forces. Okay, equilibrium of three forces. So here is the figure one uh, that is related to the equilibrium of three forces. We have three masses attached. The side masses are equal to m, that are both are equal in magnitude of small m. The force that is acting downward, that is equal to mg. So similarly the force mg is acting on this side here. So similarly the force on this side is acting, this mass is small mg, so this force is also equal to mg. Okay, now this length from between these two pulleys, this length is given, that is x, and this perpendicular length is given, that is d, and the angle is theta between here. This angle is theta, this angle is both side, this angle is equal. Okay, so this capital M is the constant mass that is here acting. Okay, not constant mass, that is capital M. Okay, acting on the center. Okay, these two masses small m the same, and this m is different from that one. Okay? That is the larger. Okay? So the whole system is in equilibrium, so we have to solve the questions. Okay, now here is the table that is given, that is on the first column we have the value of the capital M. The mass is going to change, capital M is going to change from 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.56. Okay, this capital M is going to change, this we are changing this mass capital M to 0 0.12 to 0 0.6. Okay, and when we change this mass, when we increase this mass, okay, so definitely this point will go down. Okay, so that's why the d is going to change. Okay, so d is going to change. So when d is going to change, we use d over under d square plus x square over 4. So the column is given. Okay, so for the part 2a, we have to find the missing values here. If we just find by putting the value for d over, for example here is a d, 0 0.183 is the d. So formula is d over mean 0 0.183 over square root of d square 0 0.183 square plus x square over 4. So x is 0 0.8, that is given 0 0.8 square. So we solve this and we get answer 0.416, 0.4. Similarly, when we put the value of d, small d is 0.228, 0.228 instead of this value, and value of x is 0.8, so we get same answer. We get answer 0.495, 0.495. Okay, so this part 2 shows the complete the table, so we have complete this table. Okay, now for part 2b, complete the graph in figure 2 on the page 9, plotting the two remaining points. We have to draw these 2 points that we are marked here, that we have found over here. So first of all, these 2 remaining points are along the x-axis. We have the capital M, that is 0.5. So first point is 0.5, and corresponding value of the d over under d square plus x square 4 is 0.416. This is first point. Okay, that is at 0.1. Okay, so second point is 0.6, 0.6 along x-axis, and along y-axis 0.495, 0.495. Okay, so we draw these 2 points on the table at the 9. Okay, here is the draw. So against 0.5, we have to draw, against 0.5 we have to draw the 0.416. Against 0.5 I have to repeat this, 0.5, almost here 0.5, 0.416. 0.5 is along x-axis this way, and along y-axis we have 0.416 along this way. Okay, 0.416. Okay, so this point is cross, we make the cross. Okay, now similarly next point is 0.6 and 0.6 is this one, this point is 0.6. So we move forward and we get, for example here is the point. Okay, now instead and 0.495, so 0.495 is almost here. Okay, we move from here and almost here. Okay, here cross is the. Now we can check because it's difficult to hear from the on the. We can check 0.6 here. 0.6, almost here. This one. Okay, this one is the cross point. Now we join all the points. Now we join all the points straight by way. Join all the points. In order to have the best fit, we have to complete. We have to join 3 to 4 points must, because there are more than 3 points, so we can draw 3 to 4 points accurately in order to have the best fit line. Best fit line. Okay, it is difficult on the laptop screen, so with using mouse it is difficult. Okay, so that's why but you can use the ruler scan to make a complete straight line. Okay, now now we have to find the slope of this graph. Okay, now another point, now we have to find the slope of this graph or gradient of this. For to see, we have to find the gradient. So for the gradient we choose 2 points. Okay, so we choose middle points. We can choose any 2 points, but we can use I choose the different middle points. Okay, against I choose different 0.4. Okay, against 0.4, this 4 I choose this point, this is point 2, this point, and I choose this point. So I use these 2 points. You can choose any 2 points. Okay, on the graph there must be the 4 or 3 or 4 points. Okay, now this is the we have to find, we need to find the slope of this or gradient of this line. Okay, so in order to find the gradient or slope of this line, we must know the ratio of rise and run. The gradient is equal to y2 minus y1 over x2 minus x2 minus x1. So this point is x2 y2, this point is x1 y1. So this is first point, this is second point. So we must know the coordinate of this point, and we must know the coordinate of this point. So these two coordinates we can just check from the table. We can also check from the graph, but it is very difficult to check from the graph, but we have the table values. Okay, so we have 0.4 is the point 2, and 0.1 is the point 1. So we choose these 2 points. Okay, so already I mentioned these 2 points here. Okay, 0.5 against 0.4. So we choose, this is x1 y1, this is x2 y2. Okay, now we choose the gradient. Gradient is equal to y2 minus y1 over x2 minus x1. So y2 is 0.495 minus y1 is 0.416. Difference between y points is, this is the rise, and the run is 0. Uh, so actually you choose different points. So if I choose second point as a 0.4, and against we choose 0.4 and 328, 328, 0.328, 0.328, 0.32. We can choose any point. 328 is the 328, this point. Okay, this point is 0.08, 0.80 point is 0. Y2 is 0.4 minus 0.4 minus 0.1. I can write at separate ways, x2 y2, and I have to rewrite this. This is 0.4, x2, sorry, first x1 is 0.1, y1 is 0.087, x2 is 0.4, and y2 is 0.3. Now x1 y1 x2 and y2, so we take the y difference and the, so we get the slope that is equal to 0.80. This is the slope or gradient. So gradient is 0.80. Okay, now Now consider the forces that act on the point A. By resolving these forces vertically, show that M is equal to, we have to prove this diagram. Diagram, okay. There are two forces. One force is acting towards this side, right side. So there are two components of this force. This force that is equal to mg, this right side force. One is this component, that is the sine component, mg sin theta, that is in case horizontal component, and this component is mg cosine theta, that is acting upward. Mg cosine component, that is this way. This is cosine component, this is sine component. How this is sine component? Because in front of angle we have sine component, the side that is bisecting this angle theta, this is the cosine component. Similarly, this component is mg sin theta again, and this the force, this force, the component is mg cosine theta. So these two cosine components are parallel, equal, they are added up, and while they are equal in opposite to this mass, downward mass, that is equal to capital mg. So if we resolve the two forces, we can write two upward, these two components, sine component will be cancelled by one another. So only in order to have the equilibrium, these two components, mg cosine components, will be equal to weight. Okay, mg cosine component, mg cosine theta for first plus mg cosine theta for second equal to capital mg, that is downward, that is acting downward. Okay, now this is equal to 2 mg cosine theta is equal to capital mg. So this g will be cancelled, so 2m cosine theta is equal to capital M. This is the our required result. 2m cosine theta is equal to 2m cosine theta is equal to. I redraw this. There are two forces. One force is this one, mg sine theta. This one is mg cosine theta, and this one is mg, and this one is sine theta. Okay, these sine components cancel, and cosine component will be opposite to this weight. W is equal to capital mg. Okay, 2 mg cosine theta is equal to capital mg. So this g is cancelled, so we have the same result. M is equal to 2m cosine. Okay, by resolving the two components. Now, no, 2d. Okay, 2d. Second, cool. Express cosine theta in terms of d and x. We have to express cosine theta in terms of d and x. Okay, and show that the gradient is equal to 1 over 2m. So from that we have to move from again from the graph. We need to find the cosine theta. Okay, this cosine theta, we have this. So I redraw the diagram so that we can find the cosine theta. Okay, I redraw the diagram for cosine. In order to find the cosine theta, this is x length, this length is x, and this length is force, that is equal to mg. This length is this is equal to theta. Similarly, on this way is angle theta, so this is also equal to m. Now this length is x, and this length is d. This length is d. From here to here, this length is d. Now we use simple trigonometry. Cosine theta is equal to base over hypotenuse. Let me define the base and hypotenuse first. From the diagram, we can see that this small d is the base. I use a different figure. This small d is base, okay, and this length is hypotenuse, angle theta, and this length is x by 2, because you can see that here from here to here we have the x by 2. So we don't know the value of hypotenuse. We know the value of base, that is equal to d, from the diagram, from the figure, but we don't know value of the hypotenuse. So first of all we have to define the hypotenuse. So hypotenuse here is equal to base square plus perpendicular square. So hypotenuse is equal to under root base square plus perpendicular. So under root of base square, base is d, From the diagram you can check d, and perpendicular is x over 2, x over 2 whole square, perpendicular square. So d square plus x square over 4, so under root. So here is the value of h. So now cosine theta is equal to, so now we can write cosine theta is equal to base is base over hypotenuse. So base is d, small d, hypotenuse is under root x square plus x square over. So this is the cosine theta. So I say this is question 1. Now we have to show that gradient is 1 over 2m. We have to prove that gradient is 1 over 2m. So before that, as you know, that in the previous question we have the value of the m is equal to 2m cosine theta. As we also know that capital M is 2m cosine theta. So we can define cosine theta from here, m over 2m small m. This is equation number 2. So we compare these two cosine values, so we get the gradient. So comparing 1 and 2, get d over under root x square plus d square over 4 equal to 1 over 2m into capital M. This is okay. If we see that, if we see that graph, on the y-axis we have this value. This is the y, and this is x. M is f, x, capital M is x, and this thing is y, and this capital M is x. So y is equal to, as we know that y is equal to mx. This is equation for the slope. This is equation for the straight line. Equation for straight line. So this m is slope or gradient. Okay, so gradient is equal to, you can see that if you compare, so gradient is equal to 1 over 2m, because this is y, this is x, so this is gradient. Y is equal to mx, so this gradient is 1 over 2m. So we have gradient is 1 over 2m, slope is 1 over 2m. Oh, here we have what we have to prove. Now determine the value of m using the value of gradient from the 2c. Okay, so we have to find the mass m. This m is the mass, not the slope. Okay, so from the, in order to find the value of m, we use the formula, we use the equation. Okay, 1 over 2m gradient, as we know that gradient is 1 over 2m, where m is the mass, is the gradient. So gradient of value is 0.806. We already found 1 over 2m. So m is equal to 1 over 2 into 0.806. So when we divide 1 over 2 into, so we get 0.620. So the value of 0.620, value family is 0.620 kilogram. A student obtained different result for D and M when increased compared to those obtained when M is decreased. Okay. Different result for D when M is increased and compared to those when M is decreased. So when we increase the capital M, and this is a loading, this is loading. Okay, when we increase the value of M, for example, if we increase the value of M, for example, if I increase the value of 2 kilogram here, okay, or 0.2 kilogram here, okay, so its length will increase, it will bend to the 3 centimeter. This is loading. Okay, after loading it will extend to 3 centimeter. When I remove this 0.2 kilogram, mean unload, it must go to the same position, but it's not going to happen. It will not return to the same position as it comes from. So why this set of result do not agree, the question asks. So it is due to the friction at the pulley. It is due to the friction at the pulley, because due to the friction is the opposite force, okay, against the, okay, when we load, friction is different, when we unload, friction is different. So that's why friction depends on the surface. From the loading and unloading, the friction is different, so that's why we have the different results. Okay, how to remove this or how to solve this problem of different results when we load and we unload the same mass? So this problem can be solved by using, by taking the average or mean value. This problem can be solved by taking mean value of loading and unloading mean we perform different one more than one reading, and then take the mean or average value so that our result must be perfect. Okay, now